Hare Krishna, this is my 8th video and I am going to continue again the inverse trigonometric function part 4th, isn't it? So in the last video we have studied about the inverse trigonometric function and that is the part 3. Now today I am continuing again the inverse trigonometric function, that is the part 4th, isn't it? So again the problem, it is depending upon depending upon sin A plus B. What is the formula sin A plus B? Sin A cos B plus cos A sin B. Sin B. Now if there is a minus, then here also minus. What is the formula of a cos A plus B? Cos A cos B minus sin A sin B, right? And here again, what is the formula of a cos A minus B? See here, cos A cos B plus sin A sin B plus sin A sin B, right? Now the problem depending upon this formulas. Now let us take the problem. See how are the problems again. Y is equal to sin inverse A sin x plus B cos x divided by root of A square plus B square. Second one, y is equal to cos inverse, here again 3 sin root x plus 4 cos root x divided by 5. Again third, y is equal to sin inverse 4 cos log x minus 5 sin log x divided by here again 6. 5 is a 25 and 16. That is root 41, isn't it? Again fourth one, y is equal to cos inverse 2 sin e to the power x minus 3 cos e raised to x. Here again root 30, right? And the fifth one again, see sin inverse sin x plus cos x divided by root 2. Now these are the 5 problems about the inverse trigonometric function containing the same, that is the inverse trigonometric function. I have already told you that this is the vast concept, isn't it? So therefore there are the variety of problems. So again the problem depending upon this, that is the angle addition formulas sin A plus B, sin A minus B, cos A plus B and cos A minus B. Now how will you use this formula here? See here, the first problem, y is equal to sin inverse A sin x plus B cos x divided by root of A square plus B square. Now here again if you observe this, A, B and this is totally constant, these are the constant term, right? Now sin inverse A divided by root of A square plus B square, separate this sin x, separate divide B divided by root of A square plus B square cos x, right? Now see, whenever you separate this constant, the sum of the square of this two term, it is always equal to 1. Always it is, इसकी जो square, sum of the square of this two term, it is always equal to 1. या दोघांच्या स्क्वेअरचं ॲडिशन नेहमीच किती येणार आहे? 1. See, how will you get 1? A divided by root of A square plus B square whole square, B divided by root of A square plus B square whole square, it is always equal to 1. See, when you make the square of this A square, when you make the square of a square root, the root get eliminated, A square plus B square. Again, when you make the square of B, that is B square. again when you make the square of a square root, again root get eliminated, a square plus b square. Denominator is same, you can directly add the numerator, a square plus b square divided by a square plus b square get cancelled, you will get 1, isn't it? So every time in that way only the problem are get constructed, right? Therefore whenever you separate the constant like a divided by root of a square plus b square plus b divided by root of a square plus b square, then sum of their squares, it is always equal to 1, isn't it? Now since these are the constant, this constant you have to write in the form of a trigonometric constant. Because if you write instead of this algebraic constant, suppose you put the trigonometric constant, then the trigonometric constant satisfies this identity. Now suppose you put a divided by root of a square plus b square, it is equal to cos alpha, and b divided by root of a square plus b square, it is equal to sin alpha. Then what you have got here, that is the cos square alpha plus sin square alpha, it is always equal to 1. Therefore this algebraic identity satisfies the trigonometric identity. Therefore in place of this you can substitute a trigonometric constant. Therefore this y becomes sin inverse, see this is sin x, here again a divided by root of a square plus b square, that is cos alpha, isn't it, plus cos x, and here b divided by this you can write as a sin alpha. You have to substitute this constant in such a way that so that your problem should be converted in the either sin of a plus b or sin a minus b, cos a plus b or cos a minus b, isn't it? Then and only then, suppose here you will get sin of something, then sin inverse sin get cancelled, and whatever the something it is remain, you can find out the derivative of that function, isn't it? Therefore here you can apply the formula, this is a, this is b, again this is a, this is b, sin a cos b plus cos a sin b, sin x cos alpha plus cos x sin alpha, this is the formula of sin x plus alpha, right? Therefore sin inverse sin get cancelled, what is remain here, that is x plus alpha, and dy by dx, it is nothing but what here, the derivative of a x, that is always equal to 1, isn't it? Again these are the very very important, and this problem it is depending upon this formula, right? Whatever the formulas, 4 formulas I have given, that is the angle addition formulas. Here very simple, first you have to separate the constant, sum of the square of that constant, it is always equal to 1 because the problem already constructed in that way. जो काय प्रॉब्लेम आपण कन्स्ट्रक्ट करतो तो त्याच पद्धतीने करतो, म्हणून यांच्या स्क्वेअरची बेरीज किती, की स्क्वेअरची सम किती येते 1, सम ऑफ देअर स्क्वेअर इट इज ऑलवेज इक्वल टू 1, isn't it? Now you can substitute this constant in such a way that so that your problem should converted out of this 4 formulas, isn't it? I have given the 4 formulas, तर कुठल्या तरी एका याच्यामध्ये ते बसलं पाहिजे, तर त्या पद्धतीने you can give the constant, isn't it? Either sin alpha or cos alpha, you can write in that way. So since here there is a sin x, therefore I have write a divided by root of a square plus b square, it is equal to what here, cos alpha, and b divided by root of a square plus b square, it is equal to sin alpha. Now you have got sin x cos alpha plus cos x sin alpha, this is nothing but sin of x plus alpha, sin inverse sin get cancelled, y is equal to x plus alpha, therefore dy by dx, it is nothing but what here, 1, right? The derivative of x, it is equal to 1. Now simple one, there is another problem I will take, see, same procedure you have to follow up. Suppose I consider y is equal to cos inverse 3 sin root x plus 4 cos root x divided by 5. Again, what is your first step? First you have to separate the constant, cos inverse 3 by 5 sin root x plus 4 by 5 cos root x. What is your next step? What you have to do? 3 by 5 whole square plus 4 by 5 whole square, it is always equal to 1. See whether you will get 1 or not. 3 square means 9, 5 square means 25, 4 square means 16, 5 square means 25, right? 16 plus, when the denominator is same, directly add the numerator, 16 plus 9, 25, 25 divided by 25, that is always equal to 1, right? So the sum of their constant, it is always equal to what here 1. Now since there is a sine root x, this constant, that is 3 by 5, you can consider as a cos alpha, and here there is a cos x, this you can consider as a sine alpha, isn't it? Therefore y is equal to cos inverse, first you have to write sine root x, then you have to write cos alpha plus cos root x. First you have to write the term of a x, isn't it? Term of a function. Then you have to write the constant, right? तर नेहमी लक्षात ठेवा, पहिले x चा term means function लिहायचं, and then you have to write the constant, isn't it? Cos root x, and here again 4 by 5, that is nothing but what here? Sin alpha. Again here you have got cos inverse. This is a, this is b. Again this is a, this is b. Sin root x cos alpha plus cos root x sin alpha. This is the formula of sin a plus b root x plus alpha, isn't it? But there is a cos inverse, and here in the in this bracket there is a sin. But you know, sin it is converted into cos by taking the help of a pi by 2. Therefore, in place of sin you can write as a pi by 2 minus root x plus alpha, isn't it? Therefore, here cos inverse cos get cancelled. You have got pi by 2 minus root x minus alpha, and dy by dx, it is nothing but what here? The derivative of a pi by 2, that is 0. Minus sign remain as it is. The derivative of a root x, that is equal to 1 upon 2 root x, and the derivative of a alpha, that is always equal to 0, isn't it? Therefore this is the second one. Though you write cos inverse, then also you can do the problem, isn't it? In this way you can do the remaining one also. See the third problem, see, right? Third one, y is equal to sine inverse, this is 4 cos log x minus 5 sin log x divided by root 41. Root 41. Again what you have to do, separate the constant. Sine inverse 4 divided by root of 41 cos log x minus 5 divided by root 41 sin log x, right? Now see again you know, that is 4 divided by root 41 whole square plus 5 divided by root 41 whole square, it is always equal to 1. See whether it is correct or not. 4 square means 16, root of 41 square, it is equal to 41. Again 5 square, it is equal to 25. Root of 41 whole square, that is equal to 41. Denominator is same directly at the numerator. 6 plus 5, that is 11. 1 carry 1. 2 plus 1 plus 1, that is equal to 4. 41 divided by 41, you will get 1, isn't it? Therefore here again, to get this formula, what you have to do, since there is a function of a log x, so it is easy to take here 4 divided by root 41, that is equal to what here? Cos alpha, right? And 5 divided by root 41, you can write as a sin alpha. Therefore your problem, that is y is equal to sine inverse, say cos log x cos alpha minus sin log x sin alpha sin alpha. Therefore here sin inverse remain as it is. Again cos a cos b minus sin a sin b. This is the formula of cos a plus b, cos a cos b minus sin a sin b. This is the formula of cos a plus b, means this is the formula of a means log x, b means alpha, isn't it? But again the problem is, there is a sin inverse and in bracket there is a cos. Again cos you can convert in the form of a sin by taking the help of a pi by 2. Cos you can write as a pi by 2 minus log x minus alpha, right? This angle you have to subtract it. Again sin inverse sin get cancelled. What is remain here? That is pi by 2 minus log x and minus alpha, isn't it? Therefore dy by dx, the derivative of a pi by 2 0. Again minus sign remain as it is. The derivative of a log x 1 by x, and the derivative of a alpha, that is always equal to 0, right? This is about the third one, right? In the same way, I will take the fourth one. See, fourth one, fourth, y is equal to cos inverse 2 sin e raised to x minus 3 cos e raised to x divided by root 30. Again, what you have to do? You have to separate the constant, that is 2 divided by root 13 sin e raised to x minus 3 divided by root 13 cos e raised to x. Right? Again, if you observe this, 2 divided by root 13 whole square plus 3 divided by root 13 whole square, it is always equal to 1. Check this. 2 square means 4. Root 13 whole square means 13. 3 square 9. Again, root 13 whole square means 13. 9 plus 4, that is 13. 13 divided by 13, it is equal to 1. Right? So, here, since there is a sin e to the power x, 2 by root 13 you can write as a cos alpha. So that it is easy to write the formula. Again, 3 divided by root 13 you can write as a sin alpha. Sin alpha. Right? So, y is equal to cos inverse. Again, write the term of a x. Function ची term पहिले लिहिला. Sin e raised to x. 2 by root 13 you can write as a cos alpha minus cos e raised to x, and 3 divided by root 13 you can write as a sin alpha. Right? Again, y is equal to cos inverse sin a cos b minus cos a sin b. This is the formula of sin a minus b, means e raised to x minus alpha. Isn't it? No, see. Again, there is a cos inverse, and there in bracket there is a sin. Sin again you can convert in the form of a cos by taking the help of a pi by 2. Pi by 2 minus e raised to x and minus minus plus alpha. Again, cos inverse cos get cancelled. Y is equal to pi by 2 minus e raised to x plus alpha. Here again, dy by dx. The derivative of a pi by 2 0, minus sign remain as it is. The derivative of a e raised to x, and the derivative of a alpha, that is 0. Isn't it? Very simple. Now I will take the last ones here. That is fifth one. Y is equal to sin inverse sin x plus cos x divided by root 2. Right? Now again, if you separate this, sin inverse 1 by root 2 sin x plus 1 by root 2 cos x. Right? Again, you know 1 by root 2 square plus 1 by root 2 square, that is equal to 1. But here you can write the another constant, that is here, the sin pi by 4, sin inverse as it is. This is sin x remain as it is, and here 1 by root 2 you can write as a cos pi by 4. Because the value of a cos pi by 4, that is always equal to 1 by root 2. Isn't it? Therefore, in place of 1 by root 2, you can substitute cos pi by 4, right? Directly, because this is one of the constant. Again, cos x. And here again, you can write as a sin pi by 4. Now, it's quite simple. Y is equal to sin inverse. Again, this is A, this is B. X, that is A, again B, means sin A cos B, sin x cos pi by 4 plus cos x sin pi by 4. This is the formula of x plus pi by 4, sin of x plus pi by 4. Again, sin inverse sin get cancelled. What is remain? X plus pi by 4. Therefore, dy by dx, it is nothing but what here 1. Isn't it? Therefore, again, the derivative of a x, it is equal to 1. Right? So, here, these are the 5 problems we have done, and which is depend upon the angle addition formulas, that is sin a plus b, sin a minus b, cos a plus b, and cos a minus b. Right? Now I will take the another one. See here, the inverse. The problem of a inverse trigonometric function, it is depend upon the every formula, but the differentiation and the that is the means the division of a problem the differentiation of a problem of the inverse trigonometric function, they have not given cleared in the exercise, isn't it? Now they have not given the type, all the problem get mixed. You don't conclude this problem it is based on what, this problem it is based on what. There is all confusion because all the problem in the exercise are what here, mixed one, isn't it? It is depend upon the variety of a formulas, right? Because the trigonometric formulas are very vast, so many formulas are there, and there is a problem on each formula. Again the problem, say the problem based on sin 2x is equal to, that is 2 sin x cos x, and the another formula, that is 2 tan x divided by 1 plus tan square x, right? Now again the problem depending upon the first formula. See the problem here, I will take, that is sin 2x root of 1 minus x square. Here again second one, y is equal to cos inverse 2 root x, here 1 minus x. Again third, y is equal to sin inverse, this is 8x and 1 minus 16x square. Here again fourth one, y is equal to cos inverse 2 e raised to x log x root of 1 minus log x whole square, isn't it? And the fifth one, y is equal to sin inverse 2 sec 3x root of 1 minus sec square 3x. Now see, I will take the first one, say, that is y is equal to sin inverse 2x root of 1 minus x square. Now here you have to make such a substitution so that in bracket you should get the formula, that is 2 sin x cos x, isn't it? And generally you have to remember, suppose there is a 1 minus x square, then generally put x is equal to sin theta or cos theta, but here you have to give the preference to only sin theta, right? No need to give the preference to the cos theta, though you can substitute the cos theta, but give the preference to sin theta. If root of 1 plus x square, then you always substitute x is equal to tan theta, or you can substitute cot theta, again give the preference to what here, tan theta. If again root of x square minus 1, then you have to substitute x is equal to sec theta or cosec theta, again you have to give the preference to what here, sec theta. Why you have to substitute, make a substitution like this? Suppose you put sin theta, 1 minus sin square theta, that is cos square theta, and out of root you will get cos theta, because the square of a cos square theta you will get what here, cos theta. Here again you have got 1 plus tan square theta, it is nothing but sec square theta, therefore out of the root you will get sec theta. Again sec square theta minus 1, it is nothing but tan square theta, again out of the root you will get what here, tan theta. By substituting this substitution, this that is sin theta tan theta, you will get the square term in the root, square term in the square root, and when you get the square term in the square root, you can find out the root of that function. It is quite easy. Therefore you have to make the substitution like this. Means whenever you have to imagine any problem, so you have to remember this. If root of 1 minus x square, you can substitute sin theta. Root of 1 plus x square, you can substitute tan theta. Root of x square minus 1, you can substitute sec theta, isn't it? So here make the substitution. Here you have to put x is equal to sin theta. Now see, you have got, that is y is equal to sin inverse, here 2 sin theta root of 1 minus sin square theta, right? Now again y is equal to sin inverse 2 sin theta root of 1 minus sin square theta cos square theta, and out of root you can write cos theta, isn't it? Therefore y is equal to sin inverse 2 sin theta cos theta. This is the formula of a sin 2 theta, right? Again sin inverse sin get cancelled, you will get 2 theta. Y is equal to 2, but what is theta? x is equal to sine theta, therefore theta is equal to sine inverse of x, isn't it? Therefore here this is sine inverse of x, and dy by dx, it is nothing but to remain as it is. And what is the derivative of sine inverse x? 1 upon root of 1 minus x square. So this is about the problem which is depend upon the formula, that is sin 2x is equal to 2 sin x cos x, right? ब्रॅकेट मधली टर्म जी आहे ती बघून तुमच्या लक्षात यायला पाहिजे की नेमकं काय करायचं तिथे. Therefore the formulas, the asset of a formulas, it's very important. You should know the every trigonometric formula, that is the sin 2 theta, cos 2 theta, tan 2 theta, sin 3 theta, cos 3 theta, tan 3 theta, double angle, triple angle, angle addition, factorization formulas, defactorization formulas. You should know the values also, isn't it? So you should know all the things about the trigonometric function. You should know also the inverse trigonometric formulas, isn't it? Unless and until you don't know the formulas, you can't imagine the anything and you can't proceed the problem, isn't it? Because this is the vast course. You can't by heart the problem. तुम्ही टेन्थ सारखं by heart करू शकत नाही. You have to imagine. Therefore the concept of a problem, it's very important, right? Therefore the concept you have to study through my lecture, and therefore I make the division like this. I have given the problem on the every formula, right? So that you can identify whether this problem it is depend upon which formula, where you, in this problem what you have to do. For that purpose I have given the details for you. Therefore while studying or while when you see my lecture or when you study my videos, then carefully study this, and whatever I am going to tell you, that you have to take very seriously, isn't it? So suppose I consider the second one, say cos inverse, that is 2 root x and 1 minus x. Now there is no x square, but what can you do? See here, your imagination, this is root x, and here this x you can write as a root x whole square. Means what you have to actually substitute? Root x is equal to what here? Sin theta. Right? Therefore root x square means what here? X is equal to sin square theta, right? And whenever root x is equal to sin theta, theta is equal to sin inverse of root x, right? Therefore y is equal to cos inverse, this is root 2, root x means sin theta. Here again, that is root x whole square, it is nothing but what here? Root x, that is x means what here? X is equal to sin square theta. Therefore here you can write 1 minus sin square theta. Again y is equal to cos inverse 2 sin theta, 1 minus sin square theta cos square theta out of root cos theta. Again the formula is cos inverse. This is the formula of a sin 2 theta, but there is a cos inverse, and here in bracket sin, again you have to convert sin in the form of a cos by taking the help of a pi by 2 minus 2 theta. Again cos inverse cos get cancelled, y is equal to pi by 2 minus 2, and what is theta here? The theta, it is nothing but sin inverse root x. Again dy by dx. See here, the derivative of a pi by 2, that is 0. Minus 2 remain as it is. Again you have to apply the chain rule. Here you have to substitute u. Sin inverse u, what is the derivative of a sin inverse u? 1 upon root of 1 minus u square, means 1 upon root of 1 minus root x square means x. And again what is the derivative of a root x? That is 1 upon 2 root x. 2 to get cancelled. Here you have got minus 1 divided by root x and root of 1 minus x. Since root a, root b, you can write as a root ab. Here also you can make in a one root, that is x into 1 x and x into x, x square. In this way also you can give the answer or write the answer, right? This is about the second one, right? Now I will take the third one. See, how will you do this? And here again y is equal to sin inverse 8x root of 1 minus 16x square. Again your problem is where you have to substitute sin theta, isn't it? Therefore, what you have to do, you have to bring this term into this formula. Here what do you want? 2. Therefore, what you have to do, when you take the 2 from 8, what is remain? 4x, right? And here again, what you can write, 16x square you can write as a 4x square. Means obviously you have to substitute 4x is equal to what? Sine theta. Therefore, theta is equal to what? Sine inverse of 4x. Therefore, y is equal to sine inverse. This 2 remain as it is. 4x, it is nothing but sine theta, and root of 1 minus 4x square means sine square theta, and you know 1 minus sine square theta, it is equal to cos square theta, and that is nothing but what here? Cos theta, isn't it? 1 minus sine square theta, cos square theta, and root of cos square theta, that is equal to cos theta. Again you have got the formula, that is sine inverse. This is sine 2 theta. Sine inverse sine get cancel. Y is equal to 2 theta. Y is equal to 2. Theta means sine inverse of 4x. Right? Here again, very simple. dy by dx. 2 remain as it is. Again substitute u. You have to apply the chain rule. Sine inverse u, what is the derivative of sine inverse u? 1 upon root of 1 minus u square, means what here? 16x square. And what is the derivative of 4x? That is equal to 4. Right? Therefore, 2 into 4, that is always equal to 8, and divided by root of 1 minus 16x square. Isn't it? In the similar way, I will take here the last one here, right? The fourth you can do yourself. See. Suppose I consider y is equal to sine inverse 2 sec 3x root of 1 minus sec square 3x. See. Now where you can substitute? You can substitute sec 3x. It is equal to sine theta. Right? Therefore, theta is equal to sine inverse of sec 3x. Right? Here you can put log x is equal to what here? Sine theta. In the fourth one, and theta is equal to what here? Sine inverse of log x. Right? In this way you can proceed any problem, you can do any problem, right? Therefore here, if you substitute sec 3x is equal to sine theta, then theta is equal to sine inverse of sec 3x. Now it's very simple again, sine inverse. This is 2 sine theta, and again root of 1 minus, this is sine square theta. 1 minus sine square theta, again cos square theta, and root of cos square theta, it is equal to cos theta 2 sine theta cos theta. Right? Again this is the formula of sine 2 theta. Again sine inverse sine get cancel. What is remain? 2 theta. Here again what is 2? What is theta? That is equal to sine inverse of sec 3x. Right? Now again, see the importance of the chain rule. If you know the chain rule, you can do the any type of a problem, different type of a derivatives we have given. That is the inverse trigonometric function, and the last we have studied the chain rule, isn't it? Here again, see, again 2 remain as it is. Here again you have to substitute u. The derivative of a sine inverse u, 1 upon root of 1 minus u square, means sec square 3x. Again what is the derivative of a sec 3x? Again put u. Sec u, what is the derivative of a sec u? Sec u into tan u, means sec 3x into tan 3x, and the derivative of a 3x, that is 3. 3 to the 6, 6 sec 3x tan 3x, and here again divided by root of 1 minus sec square 3x. Right? So this is about the problem which is based on the sine 2x, that is 2 sin x cos x. This is only the first formula of the sine 2x. Now I will take the second formula. See here. Second formula. How will you get the problem on this? See. Now here second formula, y is equal to sine inverse 2x divided by 1 plus x square. Second one, y is equal to cos inverse 6x divided by 1 plus 9x square. Third one, y is equal to sine inverse 2 raised to x plus 1 divided by 1 plus 4 raised to x. Fourth one, y is equal to sine inverse 2 log x divided by 1 plus log x whole square. Here again, fifth one, y is equal to cos inverse 2 e raised to root x divided by 1 plus e raised to 2 root x. Again very simple. See the short trick. What is the answer of this? You have to take the derivative of this 2x 2. The denominator remain as it is. Right? The derivative of a 6x, that is 6. But since this is the cos inverse, therefore minus result you will get 1 plus 9x square. Write down the result and see whether you will get this result or not. Again, the derivative of a this, that is 2 raised to x plus 1 log 2, and here again 1 plus 4 raised to x remain as it is. Here what is the derivative? Log x 1 by x, and here 1 plus log x, the denominator remain as it is, isn't it? See, right? Here again, whenever there is a cos function, you have to write the minus sign. Minus 2 remain as it is. E raised to root x, derivative of e raised to root x, e raised to root x, and the root x derivative, that is 2 root x, and this function, the denominator remain as it is, right? Therefore 2 to get cancelled, this result you will get. Write down the result and see whether you will get these results or not. The first problem, that is again very simple. See, here y is equal to sine inverse 2x divided by 1 plus x square. Now to get this formula, what you have to do? Obviously you can substitute x is equal to tan theta, right? Therefore theta is equal to tan inverse of x. Therefore y is equal to sine inverse 2 tan theta divided by 1 plus tan square theta, right? Again, y is equal to sine inverse 2 tan theta divided by 1 plus tan square theta. This is the formula of sine 2 theta, right? Again sine inverse sine get cancelled, 2 theta, y is equal to 2. What is theta? Tan inverse of x, right? Therefore what is dy by dx? It is nothing but 2. And what is the derivative of a tan inverse x? 2x derivative 2 and divided by 1 plus x square. Got it? Right? Again see the second one, that is y is equal to cos inverse 6x divided by 1 plus 9x square. Now what you have to do? To get this formula, first you required, that is 2. When you take 2 from the 6, what is remain here? This is 3x. And again in the denominator, 9x square you can write as a 3x whole square. Now your problem, it is in a standard form. Now you can substitute, that is 3x is equal to tan theta. Therefore theta is equal to what here? Tan inverse of 3x, right? Now again y is equal to, this is cos inverse, this you can write as a 2 tan theta divided by 1 plus tan square theta, and this is the formula of what? Sine 2 theta. But the problem is, again there is a cos inverse and in bracket there is a sine. Therefore what you have to do? Cos inverse. Sine you can convert in the form of a cos by taking the help of a pi by 2 minus theta. Again cos inverse cos get cancelled. What is remain? Y is equal to, see, y is equal to, you have got as a pi by 2 minus 2 theta, right? Y is equal to pi by 2 minus 2. What is theta? Theta, it is nothing but tan inverse of 3x, right? Dy by dx. Again pi by 2 0, minus 2 remain as it is, right? Here again apply the chain rule. here substitute u. The derivative of a tan inverse u 1 upon 1 plus u square means 9x square. And the derivative of a 3x, that is equal to 3. Therefore, here you have got minus 6 divided by 1 plus 9x square. That I have told you already. The derivative of a 6x 6. The denominator remain as it is. But since there is a cos inverse, you will get the minus sign. Isn't it? That is the second one. Now, if you observe the third one, see, you will get the third problem here. And the remaining two, you can do yourself. Third one, sine inverse 2 raised to x plus 1 divided by 1 plus 4 raised to x. Again, your problem is, how will you write this 2? Suppose you take 2 here. That is nothing but what here 2 into this 2 raised to x plus 1 you can write as a 2 into 2 raised to x. When the base is same, you can add indices, and the 4 raised to x you can write as a 2 raised to x whole square. Why? See here, 4 raised to x. Here 4 means what here? 2 square whole to the power x, right? Now 2 square whole square, that is 2 square whole to the power x, you can exchange the power, because a raised to m whole to the power n, it is nothing but a to the power mn. Now here, suppose you write n here and m here, again you will get the same result. Therefore, the power it is multiplied to the power, therefore you can exchange the power. This you can write as a 2 raised to x whole square. Therefore, 4 raised to x whole square you can 4 raised to x you can write as a 2 raised to x whole square. 16 raised to x you can write as a 4 raised to x whole square. 25 to the power x you can write as a 5 raised to x whole square. 36 to the power x you can write as a 6 to the power x whole square. 49 to the power x you can write as a 7 to the power x whole square. In this way, you can write such a term, isn't it? Therefore, 2 raised to x plus 1 you can write as a 2 into 2 raised to x, because when the base is same you can add indices, and the 4 raised to x you can write as a 2 raised to x whole square. Now here again you can substitute 2 raised to x is equal to tan theta. Therefore, theta is equal to tan inverse of 2 raised to x. Again you have got the formula. Y is equal to sine inverse. Again 2. See, 2 raised to x you can write as a tan theta divided by 1 plus tan square theta. Here again the formula of what? Sine 2 theta. This is the formula of a sine 2 theta. Again sine inverse sine get cancel. What is remain here? Y is equal to 2 theta. But what is theta here? Tan inverse of 2 raised to x. Again dy by dx. 2 remain as it is. What is the derivative of a u here? Tan inverse u 1 upon 1 plus u square. 2 raised to x whole square means what here? 4 raised to x. Again the derivative of a 2 raised to x, that is 2 raised to x into log 2. Right? And again the numerator you can write as a 2 raised to x plus 1 log 2 divided by 1 plus 4 raised to x. Right? The remaining two problem you can do yourself. Log x you can substitute as a tan theta, and e raised to root x also you can substitute the tan theta. Right? You can do yourself here, do the practice on this formula here. Right? So again the problem based on the another formula, that is cos 2 theta. The first formula of a cos 2 theta, that is equal to cos square theta minus sin square theta. Right? The second one, 1 minus 2 sin square theta. Third one, 2 cos square theta minus 1. And the fourth one, 1 minus tan square theta divided by 1 plus tan square theta. Right? Sin 2 theta चे किती formula आहेत? 2. And what is, how many formulas of a cos 2 theta? There are the 4. But we have to take the problem, HR problem nahi. You have to take the problem on this formula, and on this formula. On the basis of this formula, we have to perform, we have to do the problem on what here? Inverse trigonometric function. Right? So, continuing the inverse trigonometric function, and I am going to take the problem on this cos 2 theta. That is cos 2 theta is equal to 1 minus 2 sin square theta. Again 2 cos square theta minus 1 Here again 1 minus tan square theta divided by 1 plus tan square theta, right? See the first one, या फॉर्म्युल्यावर बघा. Here again y is equal to cos inverse 1 minus 2x square, y is equal to sin inverse 1 minus 2x. Third, y is equal to cos inverse 1 minus 32x square. Fourth one, y is equal to sin inverse 1 minus 2 log x whole square. And fifth one, y is equal to sin inverse 1 minus 2 cos square x, 1 minus 2 cosec square x, right? Now I will take one first simple one, that is first one, y is equal to cos inverse 1 minus 2x square. Now to get this formula, that is the first one, what you have to do? You have to substitute, obviously x is equal to sin theta. If you substitute x is equal to sin theta, y is equal to cos inverse 1 minus 2 sin square theta. And 1 minus 2 sin square theta, it is nothing but what here? That is the formula of a cos 2 theta, right? Again, cos inverse cos get cancel. What is remain? 2 theta. Therefore, y is equal to 2 theta. What is theta? Sin inverse of x. Therefore, dy by dx, it is equal to what? 2 remain as it is. The derivative of a sin inverse x, 1 upon root of 1 minus x square. Isn't it? Can you do the another problem here? I will take third one. Here you can write, in place of x, you can write what here? Root x square. And here you can substitute root x is equal to what here? Root x, it is equal to sin theta. Now here, take the third one. See, third one. That is y is equal to cos inverse 1 minus 32x square. Here again, if you observe this, cos inverse 1 minus, what do you want? Here 2, right? Again, if you take 2 from 32, what is remain? 16x square, right? 16x square. And the 16x square you can write as a, see, 1 minus 2, and the 16x square you can write as a 4x whole square. Now you can substitute 4x is equal to what? Sin theta, right? Therefore theta is equal to sin inverse of 4x, right? Y is equal to cos inverse 1 minus 2 4x. In place of 4x you can substitute sin theta, therefore 1 minus 2 sin square theta. And this is again cos inverse 1 minus 2 sin square theta. This is the formula of a cos 2 theta. Again cos inverse cos get cancel. What is remain? 2 theta. Here again y is equal to, say, what is 2 theta here? Theta. Theta, it is nothing but sin inverse of 4x, right? And here again dy by dx, 2 remain as it is. Apply the chain rule. Sin inverse u, the derivative of a sin inverse u, 1 upon root of 1 minus u square, means 4x square means 16x square. And the derivative of a 4x, that is equal to 4. Therefore here you have got 8 divided by 1 minus 16x square, right? This is about the third one. Now here in place of this log x, you can substitute again what here? Sin theta. And in place of cosec x, you can substitute sin theta, right? If you substitute log x is equal to sin theta, then you have got theta is equal to sin inverse of log x, right? And here suppose in place of cosec x, you substitute sin theta, then again theta is equal to sin inverse of cosec x. Here you have got, isn't it? Now in this way you can do the remaining one, isn't it? So write down all the 5 problems and do the remaining problem, isn't it? Now I will take the problem on this second formula, that is 2 cos square theta minus 1. See, another one, that is first y is equal to cos inverse 2x square minus 1. Second one, y is equal to cos inverse 18x square minus 1. Third one, y is equal to sin inverse 2 9 to the power x minus 1. Fourth one, y is equal to sin inverse 2 e raised to 2x minus 1. And the fifth one, y is equal to sin inverse 2 tan square x minus 1. Isn't it? Now again, as usual, I will take the first one. Say y is equal to cos inverse 2x square minus 1. Again, what you can substitute? You know what you have to substitute. All of you know what you can substitute, because we want the second formula. The problem, it is based upon the second formula. Obviously, x is equal to cos theta. Therefore, theta is equal to cos inverse of x. Y is equal to cos inverse of, this is 2 cos square theta minus 1. Isn't it? In place of x, you have to substitute cos theta. Therefore, here you have got 2 cos square theta minus 1. Again, cos inverse 2 cos square theta minus 1. This is the formula of what? Cos 2 theta. Again, cos inverse cos get cancelled. Here 2 theta. Y is equal to 2 theta. Theta means what here? Cos inverse of x dy by dx. 2 remain as it is. The derivative of a cos inverse x, that is minus 1 upon root of 1 minus x square. Right? So this is about the first problem, and which is depend upon the formula cos 2 theta is equal to 2 cos square theta minus 1. Right? Suppose I take the second one. See, second one, y is equal to cos inverse 18x square minus 1. Again, what do you want? Here you want 2. Therefore, when you take 2 from 18, what is remain? 9x square. Right? Here you can write 9x square. 9x square minus 1. And the 9x square you can write as a, this 2 remain as it is. 9x square you can write as a 3x square minus 1. Now, where you have to substitute? Obviously, you have to substitute 3x is equal to cos theta. Therefore, theta is equal to cos inverse of 3x. Right? Now here, y is equal to cos inverse 2. The 3x whole square you can write as a cos square theta minus 1. Isn't it? This is 3x. 3x is equal to cos theta. Therefore, 3x square, it is nothing but cos square theta. Again, if you observe this, this is the formula of a cos 2 theta. Right? Again, cos inverse cos get cancelled. Y is equal to 2 theta. Y is equal to 2. What is theta? Theta, it is nothing but cos inverse of 3x. Right? Therefore, dy by dx, 2 remain as it is. Again, apply the chain rule. Cos inverse u, the derivative of a cos inverse u, minus 1 upon root of 1 minus u square means 9x square, and the derivative of a 3x, that is equal to 3. Therefore, the result is minus 6 divided by root of 1 minus 9x square. Right? This is about the second one. Right? Now, I will take the third one, and the remaining fourth and fifth you can do yourself. Right? So, the third one, see. Third one, y is equal to sin inverse 2 9 raised to x minus 1. 9 raised to x, how will you write this? See, अभी बताया था मैंने. Now this you can write as a 3 raised to x whole square. आत्ता just सांगितलेलं आहे मी. 9 raised to x you can write as a 3 raised to x whole square. Obviously you can substitute 3 raised to x is equal to cos theta. Therefore, theta is equal to cos inverse of 3 raised to x. Therefore, y is equal to sin inverse 2 remain as it is. 3 raised to x whole square means cos square theta minus 1. And again, this is the formula of that is cos 2 theta. Again the problem is there is a sine inverse and in bracket there is a cos. Therefore what you have to do, the cos you can convert in the form of a sine by taking the help of a pi by 2 minus 2 theta. Again sine inverse sine get cancel. What is remain here? That is y is equal to pi by 2 minus 2 theta. What is theta? See, the theta, it is nothing but cos inverse of 3 raised to x, right? Therefore dy divided by dx, the derivative of a pi by 2 0, minus 2 remain as it is. Again cos inverse u, apply the chain rule. What is the derivative of a cos inverse u? Minus 1 upon root of 1 minus u square, means 3 raised to x whole square. 3 raised to x whole square means 9 raised to x. And what is the derivative of a 3 raised to x? 3 raised to x log 3, isn't it? Therefore minus minus plus 2, 3 raised to x log 3 divided by root of 1 minus 9 raised to x, isn't it? So this is about the third one. Now you can do the fourth one and the fifth one also yourself. Here in place of e raised to 2x, here you can substitute e raised to x whole square and e raised to x is equal to cos theta, and here in place of tan x you can substitute what here? Cos theta. Therefore theta is equal to cos inverse of tan x, and here if you substitute cos theta, then theta is equal to cos inverse of e raised to x, right? Now I will take the last one here, say, that is 1 minus tan square theta divided by 1 plus tan square theta. See, the problem depending upon the third formula, that is again cos inverse 1 minus x square 1 plus x square. Here second one, y is equal to sine inverse 1 minus 4x square 1 plus 4x square. Third one, y is equal to cos inverse 1 minus 9 raised to x or 4 raised to x 1 plus 4 raised to x. Fourth one, y is equal to sine inverse 1 minus e raised to 4x 1 plus e raised to 4x. And the last one, y is equal to cos inverse 1 minus sec square x divided by 1 plus sec square x, right? The problem depending upon this third formula, that is cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. Again obviously, see, the first again easy. To get this formula, again obviously what you have to substitute? In place of x you have to substitute tan theta. Therefore x is equal to tan theta, theta is equal to tan inverse of x, y is equal to cos inverse 1 minus tan square theta divided by 1 plus tan square theta, right? Again here you have got y is equal to cos inverse of, this is the formula of a cos 2 theta, right? Again cos inverse cos get cancel, here 2 theta, y is equal to 2. What is theta? Tan inverse of x. Therefore dy by dx, 2 remain as it is. The derivative of a tan inverse x 1 upon 1 plus x square, right? The derivative of a tan inverse x, that is 1 upon 1 plus x square. Simple, isn't it? Therefore the result is 2 divided by 1 upon 2 divided by 1 plus x square, right? Now I am going to take the second one. See, the second one. Second one, y is equal to sine inverse 1 minus 4x square 1 plus 4x square. How will you manage the problem? See yourself. Now you have got the idea, right? We have done the so many problems. From that you will get the idea here. This 4x square you can write as a 2x whole square, and here no 4x square you can write as a 2x whole square. Now where you can substitute? 2x is equal to tan theta. Therefore theta is equal to tan inverse of 2x, right? again y is equal to sine inverse, here 1 minus, in place of 2x you can substitute tan theta, means tan square theta divided by 1 plus tan square theta, and again this is the formula of cos 2 theta, sine inverse cos 2 theta. Again the problem is there is a sine inverse and in bracket there is a cos. Again you can convert the cos in the form of a sine by taking the help of a pi by 2, sine of pi by 2 minus 2 theta, right? Again sine inverse sine get cancel, y is equal to pi by 2 minus 2 theta, right? Y is equal to pi by 2 minus 2, what is theta? Tan inverse of 2x, right? So dy by dx, the derivative of a pi by 2 0, because this is a constant function, minus 2 remain as it is. Here you have to apply the chain rule. The derivative of a tan inverse u 1 upon 1 plus u square means 4x square, and the derivative of a 2x, that is equal to 2, right? Therefore minus 4 divided by 1 plus 4x square, isn't it? So this is about the second one, right? Now I will take the third one, right? Here you can write e raised to power 4x, that is e raised to 2x whole square, and here sec x is equal to, you can substitute as a cos theta, and here e raised to 2x whole square means what here? 4x. Therefore e raised to 2x you have to substitute as a tan theta, and here sec x you have to substitute as a tan theta, right? Now I will take only the third one, that is say y is equal to cos inverse 1 minus 4 raised to x 1 plus 4 raised to x. How will you write this again? Y is equal to cos inverse, here we want the square term, obviously 4 raised to x you can write as a 2 raised to x whole square, and here again 1 plus 2 raised to x whole square, right? Now here again you have to substitute 2 raised to x is equal to tan theta, therefore theta is equal to tan inverse of 2 raised to x, right? Again y is equal to cos inverse, this is 2 raised to x whole square you can write as a tan theta, 1 minus tan square theta divided by 1 plus tan square theta, right? Again this is the formula of cos 2 theta, y is equal to cos inverse, here cos 2 theta, again cos inverse cos get cancel, what is remain 2 theta, right? Again y is equal to 2 remain as it is, what is theta? Tan inverse of 2 raised to x dy by dx, 2 remain as it is. Here again apply chain rule, here you have to substitute u, the derivative of a tan inverse u 1 upon 1 plus u square means 2 raised to x whole square, the derivative of a 2 raised to x, that is 2 raised to x log 2, right? Therefore this you can write as a 2 into 2 raised to x, you can write as a 2 raised to x x plus 1 log 2, and here again 1 plus 4 raised to x, right? So the problem, it is depending upon the formula, that is cos 2 theta, and there are the three formulas: 1 minus 2 sin square theta, 2 cos square theta minus 1, and 1 minus tan square theta divided by 1 plus tan square theta. So here we have finished in this session, we have finished, that is what here, sin 2 theta 2 formulas, cos 2 theta 3 formulas, and again we have finished, that is the formula angle addition, that is sin a plus b, sin a minus b, cos a plus b, cos a minus b. In the next session again we have to perform the problem on tan 2 theta, always sin 3 theta, cos 3 theta, tan 3 theta, isn't it? And after that again there are the unusual one, and there again you have to manage it differently. Unusual problems are there, the different ideas are there, that also we have to take, isn't it? But this is the regular process, right? The problem depending upon this problem, that is a regular one, isn't it? But some problems are like this, there you have to imagine, there you have to manage the problem, isn't it? So that problem I will take in the next session. Next session I will take the problem on what here? Tan 2 theta, sin 3 theta, cos 3 theta, and tan 3 theta, and after that I will take the unusual one. So the student, if you like my video, please share it and subscribe my channel.